Afternoon to all. Today we are going to discuss about the transport layer protocol, that is your TCP in communication network subject. So the transport layer protocols already we have discussed about the UDP in the previous video. Today we are going to discuss about your TCP, that is a transmission control protocol. The transmission control protocol is nothing but a connection oriented reliable protocol. So if it is a connection oriented, we have to go for connection establishment. So it is using a three-way handshake methodology. One is connection establishment, second it should be data transfer, and the third should be the connection tear down or your connection termination phase. So it uses the combination of your flow control methodology, go back in, and selective repeat protocols to provide reliability. Unless UDP doesn't use any flow control methodology, and finally it uses the checksum for your error control, that is your error correction. So these are the services offered by the TCP. So the TCP provides process to process communication. So the what is process to process communication? Using port number from client to server, and it will be communicating. And the second should be the stream delivery service. It should be an UDP is a stream oriented protocol. So TCP on the other hand allows the process to deliver a stream of bytes. What is the stream of bytes? It will be grouping some of the bytes of data as a stream, and it will be transferring the bit from one to the other. How it works is it looks like a see this, you are having a client as well as a server. In the sending process, the TCP will be as a stream of bytes, like a tunneling process. It will be transmitted, and the receiving side will be received as segments. And the third one should be the sending and receiving purpose. The sending and the receiving purpose, as we don't have the capability for writing and reading data at the same rate. So TCP uses buffer for storage, one in the sending buffer and the receiving buffer, one for each direction. And both the buffers will be operating in a cyclic manner. So say this, you're having a buffer in the sender side as well as the receiver side. The first one shows a buffer. Some data has in the sending process starts to send, and some has written but not sent. That what it means is it has started initiation and it is not receiving the acknowledgement from the return side. After that only the stream of bytes can be transmitted. Okay. So then in the receiving process, you will be having some bytes is received and some bytes is not received but not read. What is the meaning of that? The acknowledgement from the receiving side is not sent back after reading. So it is waiting in the buffer till the process is getting over. And the next is segments. So the data is in the stream of bytes. We are combining the stream of bytes should be in the form of segments. So it is nothing but a group of bytes together in a packet called a segment. So the TCP, what it do is it adds header to each segment for controlling the control purpose. What is the control purpose? At the end, it should have to retrieve the data. So this is the segment which is having received. So for that, you'd be adding a header. In that header, the segment address. The segment address is numbered as a sequence number, and the segments are encapsulated in the transmitter side, and in the receiving side, it should be decapsulated. So this is what segment 1 to segment n with the header. It is transmitted from the sending side to the receiving side. This diagram illustrates the flow of the segment. In the segment, each segment will be having more number of packets. So first the segment is having in this example 3 packets, and that means 3 bytes of data, and the second last segment is n segment is having 5. So it will be depending on the size, it will be getting varying as per the request sent by the client or the server. Next is full duplex. As I told you, the stream of bytes is transmitted. Both the client and server can communicate at a time, both directions. And because of the sending and the receiver having in the queue process, it will be holding on, and it will be getting the data, giving the data from one side to the next side. And the next service offered by the TCP is multiplexing and demultiplexing. And this multiplexing will be used for the sender, and the demultiplexing and the receiver, as it is a connection-oriented protocol, it should be required. Next is connection oriented. So this is a very important it is a feature or the service offered by the TCP, because the UDP is a connectionless protocol. We are using for connection establishment itself as a phase. So that is nothing but establishing a logical connection between the first one. And the second should be the data transfer, that is the data are exchanged in both directions. And the third should be the tear down phase, that is the connection is terminated. Their service is a reliable service because of using the checksum as well as the acknowledgement mechanism for transmission as well as reception. This TCP provides a reliable service. So these features, what are the services offered, will be implemented with the help of the numbering system. We are using the two numbering system. One should be the sequence number and another should be the acknowledgement number. So the acknowledgement number and the sequence number is represents a byte number, not the segment number. So how much bytes? So as in the stream delivery, I show you the segment 1 is having 3 bytes and the last one should be having 5 bytes in this diagram. Similarly, it will be defined the number of number of packets. So that will be bytes. Okay. So byte number TCP uses totally from 2 power 32 minus 1. That means 0 between 0 and 2 power 32 minus 1. But it don't want to start from 0. It randomly initiates in the request message itself. Then should be the sequence number. After the bytes have been numbered, it should be assigning a sequence number to each segment that is being sent. The sequence number will in each direction will be starting with the ISN, that is initial sequence number, which is a random number. And if you are going to transmit 1,000 bytes of data, then after getting the 1,000 bytes, the last byte should be, for example, if it is starting is 8,000, at last it should be 9,000. So from 8,001 to 9,000, this 8,001 should be the initial sequence number. So it should be acknowledged. So for that, you need an acknowledgement number. The acknowledgement number defines the number of the next byte. So in this previous example, which I told you, up to 9,000 means the acknowledgement number will be 9,001. So 9,000 plus 1, it adds 1. That means it is expecting the next number to be received. So the packet in TCP is called the segment. These are the features. So what should be the segment format? So it will be having a header structure with 20 to 60 bytes. Whereas this UDP has the header structure with 8 bytes. So in this 20 to 60 bytes, 20 bytes is always used. And the remaining 40 bytes, that is up to 60 bytes we are telling, the remaining 40 bytes should be the option or optional case whenever it is required. So how it is dividing this 20 bytes? So in this 20 bytes, each will be divided as 32 bits, 32 bits, 32 bits, 32 bits. So that means 5. Okay. So first 5 bytes, which is used for source port address, that is nothing but the client address, and the next 16 bits is used for destination port address, that is nothing but the server address. And the next should be the sequence number, which we are going to start. It is represented in the 32-bit format, and the acknowledgement number that is to be expected. And at last, the header length, HLEN represents header length, which is of 4 bits. So this 4 bits, how we are going to represent? I told you it is a maximum of 60 bytes and a minimum of 20 bytes. So if it is maximum of 60 bytes means totally, so 15 into 4, it will be maximum of 15, and minimum 20. 20 should be 5 into 4, 5 into 4. So minimum value of header length should be 5. And the maximum value should be 15. So 5 it is represented as 0101 and 15 it is represented as 111. That is your header length. Maximum and minimum. Okay. So next should be reserved the 6 bits. At next, the very important thing. So you have some 6 flag bits which is used as control bits. The first should be the urgent. Second should be the acknowledgement. Third should be the push data. Fourth should be the RSC, that is nothing but reset the connection. SYN represents synchronizing the sequence number. FIN represents the final, that is to terminate the connection. So these 6 wheels will be not activated at the same time. It will be activated whenever it is transmitting acknowledgement will be activated. If it is transferring SYN, that is synchronizing to the sequence number and acknowledgement, both are activated. And while data transfer, PSH is activated, and the termination of connection FIN should be activated. Next, 16 bits of window size. This window size, what it defines is, this window size is having, that is we are using the combination of go back and selective repeat. In that, there will be a pin, we are using a window. So that window size will be represented here if it is using the flow control mechanism. And the next 16 bits for checksum, which is used for error correction. And this next 16 bits for urgent pointer, that urgent pointer will be activated whenever the URG flag is set. So the remaining options should be of 40 bytes, which will be used whenever it is required. So these are the control fields which is represented totally 6 bits. All will be activated. All will not be activated at a time. In this acknowledgement sync final will be activated mostly, and PSF will be activated whenever the data is transferred. Okay. So this is about the information of the control field which is used on the flags which are represented in your header structure. That's how it is establishing the connection, data transfer, termination. That is nothing but the operation we are going to discuss. How the operation will be discussed, as you know, it will be in the form of segments. We are going to transfer the data. If the segment is lost or corrected, it is retransmitted. But it requires for establishment, it will be 3 phases. First, we can discuss about the connection establishment. So this is how TCP synchronization, acknowledgement, synchronization by acknowledgement. Both the client and server will be going on these processes. First, connection establishment. It is in full duplex mode. So when 2 machines are connected, they are able to send segments simultaneously. After that only the data will be transferred. So it is using 3-way handshake in the connection establishment itself. So first we are going to define a client as well as a server. How it is going to transfer the data? First it will be giving the passive open, and when the server is requesting, it should be open to get the data. So the client will be sending active open. So it will be sending along with that the sequence number. So the synchronization sequence number S is activated. What is the sequence number? It is 8000. So when it is receiving that, the server is receiving that, it is acknowledgement will be sent and its sequence number will be transmitted. What is the sequence number of the server? It is 15,000. And the acknowledgement should be updated as +1, so 8001. Now the acknowledgement A as well as synchronization packet, both are sent, so both are activated. So once it is receiving, so it will be telling that the connection is open. So once the connection is open, it will be replying with that the sequence number updated by 15,001, and the acknowledgement is received. Now connection is established. The connection is open between the client as well as the server. This is your 3-way handshake. So first synchronization, then synchronization plus acknowledgement, then the acknowledgement. Next should be the connection. After connection establishment, we have to go for giving that. Sometimes if there's more data, more synchronization packets are transmitted, it will be this TCP is prone to the attack called the synchronization flooding attack. So large number of synchronization segments to be received in the server, so which will be stopping the particular service that is offering. So it is nothing but a denial of service attack. We want to validate. We want to accept the request based on validating that. So for that purpose, we are using a cookie, which will be verifying the connection request is coming from a valid IP address. Then only it will be giving the accepted. That is the connection is established. So data transfer. How it goes to the data transfer? Again, bidirectional data transfer. How it is going to do? It will be having a client as well as server. The first what is going to do, connection is establishment, as you know, the first phase. Client is sending the request with the sequence number and acknowledgement and starts pushing the data. So the P has enabled, the third bit is enabled. What is the byte? It is 8001 to 9000. Once it is receiving, it will be sending the acknowledgement. And if it is not, the another send request is sent, again the data, another 1000 bytes will be transmitted. So 9001 to 10,000 is pushing the data, it is received. After receiving fully, there is nothing received means it will be sent requesting. And now the client will be sending with the sequence number 15,000. 15,001. What is the acknowledgement received? 10,001. Why? Because the data packet before received 9,001 to 10,000. So it is incremented by 1, it will be 10,000 more after receiving the data. So now what are the things? The sequence number is already known. So acknowledgement is updated. Only the acknowledgement is updated, and what is the data? It is going to transfer as 2,000 bytes. So 15,001 to 17,000. So once it is receiving, it will be sending the request again, means from which it will be starting the data from the 10,001. The sequence number now should be 10,001. What is the acknowledgement? The last packet received is 17,000. So the acknowledgement is expecting 17,001. It is receiving and Next, all the data from the client side and the server side is received. Now we have to go for the connection termination or connection tear down. So connection tear down, again, it is nothing but a handshake problem, handshake taking, but which one is going to establish it is the final, that is F. It is again a three-way handshake. How it is going to transfer? First, active close is exhibited by client. There it will be the server. Next, it will be sending an sequence number with the acknowledgement Y. So F is enabled means FIN is active. Now it is receiving, so it is also going to close. What is the sequence number? It is X. So it will be acknowledgement with X plus 1. When plus acknowledgement is enabled, connection is closed, it will be acknowledging again with the incremented acknowledgement number Y plus 1. So now we have received the acknowledgement from both sides and the connection should be closed. So that is the three-way handshaking in again connection termination. So three-way handshaking is used in the connection establishment setup as well as in the connection termination. Sometimes there is a requirement. One side is closed, other side is not closed. Means I say the client is closing or the server is closing. It is going for half close. So what is half close? It is again active close, the same message. Acknowledgement is received, everything okay, but it is going to decrement the sequence number as Y minus 1 because it is don't want to terminate the connection. So it is going to establish, the server is going to establish the connection with another one server. Data segment acknowledgement from client to server is received, but data segment from server to client is again start to another one. So what is the sequence number? It is nothing but sum is Z. Okay. So therefore F is activated whenever it should be going to off. So one side is activated and the other side is not activated means it is nothing but the off close. The connection is closed towards one side and towards the other side it is not closed. That is nothing but your off close. So the TCP we have discussed about the services. Next, what should be the features and at last the operation in terms of three phases. What are the three phases? One should be the connection establishment, then should be the data transfer, and at last your termination of the connection. So this is what the TCP is, and it is all used in your all internet today. The TCP will be used.